Right, so in this question, they're asking us to find the tangent line. So we start with what we know, point slope form, y minus y1 equals the m, which is going to involve the derivative, times x minus x1. Now, what's weird about this question is they only give us an x value. They don't give us the y value. So that is going to be a little bit of an issue for us. So I always kind of think about this equal sign as splitting the work into two places. So if I don't have the y1 value, that is just the function evaluated at the given x value. So I just need to plug in -1 into the original function. So if I do that, I'm going to have 2 times -1 to the third. Now keep in mind, a negative raised to an odd, again, you should be able to do this without a scientific calculator. Negative raised to a cubed is going to give us a negative. So that's going to be -2. Plus 4 times -1 squared gives us a positive, so plus 4. And then minus 5 times -1 gives us a plus 5. And then the minus 3. So we are looking at 5 minus 5 plus 4. So we are looking at 4 for our y1 value. Okay, so what we can do is we can go here and we can say, and I'm going to scoot it up here, we can say y minus 4 equals. Now, the reason why I like to draw this little line through the equal sign is because on the left-hand side, you plug into f, and on the right-hand side, when you're working through your tangent line, you're going to plug into your derivative. So over here it's f, and over here it's going to be about the derivative. Now, first we have to find the derivative just for an arbitrary x. So we go up here. This is very nicely done because it's a polynomial. We can just bring down the exponent. So we get 6x squared, so the 2 times 3 gives us the 6. The square comes from subtracting 1. Then here we use our power rule. 4 times 2 gives us 8. Subtract 1, we get 8x. Now, this -5x is raised to the first power. So that really stands out to us when we see that first power. That means it's a linear term. And if it's linear, then we're just going to use the coefficient. So we will have -5. And then the -3 is a standalone all by its little lonesome constant, so it's just going to go to 0. Now, remember that for the derivative, you're not interested in the derivative involving x. You want the derivative with a x value plugged in. So you will plug in x is equal to -1, the given x value. So that will give you 6 times -1 squared plus 8 times -1 minus 5. So the negative squared is going to give us positive. 8 minus 1 gives us -8, and then minus 5. So we're looking at -2 minus 5, so that becomes -7. So our derivative is -7, and that's what we plug in for our slope. So putting this all together, here is what we are going to see. We're going to see y minus 4. Again, we found that by plugging into the function. The derivative is -7. And then x minus our x1 value, which was given, which was -1. Now, I personally don't like to see these double negatives left, so we always rewrite those double negatives as a positive, and then that becomes our point slope form for the tangent line.